Okay, that's good. The recording's also in progress. My name is Asal Rabbani. I'm lead data scientist here at H2O for the EMEA region. And today we'll be speaking about GPT models and some of the application of GPT that can be applied in enterprises, specifically from point of view on-premise solutions, because I'm sure that everyone has had already ChatGPT, the exciting things that these models can do. But our approach for today will be that we will focus on-premise, installation or on-premise setup of these models and some of the applications around that, together with our partner Exceltic. And with that, I'd like to hand over to Antonia to take this stage.
Thank you. I'm Antonio Oliva. I'm a solutions engineer for Exceltic, and I will be giving you a small introduction to the whole suite that is H2O before Asghar goes into more detail regarding GPT. H2O is a suite of applications that aims to give empower the customers with strong AI systems that are easy to implement. And to give an example of this, I will give the example of driverless AI, which sorry. There's driverless AI is after. There's 3 different areas within H2O that customers can find uses for artificial intelligence and incorporate into their products. One of the areas is the traditional AI space of text recognition, machine learning, deep learning, and smart data extraction from, for example, text documents that you can see on the left. There's also, they can put tools, so they can put them into production. So they can deploy and run these models for commercial use. They can make labeling and tuning large data quantities, very easy and customizable to a high degree, as well as offering a big array of tools and servers to host and monitor the servers running in runtime, as well as checking the performance of the models and generate alerts according to performance metrics that can be set. And third, the last area is the area of innovation. This is a developing horizon of new options for companies to adopt AI systems into new uses. There's, of course, the focus of this talk, H2O GPT, but also the plethora of already built apps found in the H2O App Store that can be customized into fitting certain needs that for minimal work and technical expertise from the personnel incorporating the new AI product. And now I will introduce driverless AI, which I believe captivates this essence of H2O of democratizing AI and building easy to implement strong applications. It still marvels me to this day, and it's a machine learning tool that can import large data sets, customize and train models for operating on those data sets, whether it's regression or classification, and get them ready for deployment and documented within minutes. In fact, whenever we demo driverless to other customers, we usually let them guide us through the demo and let them choose how they want to customize the model. So we can show them the results of their own process that they would go through whenever they use this product. And it's an excellent example of how you can make AI more accessible and it will improve productivity with minimal cost of training and personnel hiring for operating complex systems, and it's all thanks to H2O. We can, thanks to this array of tools and all of the products that H2O offers, it continues to be ranked as one of the biggest pioneers in the world of artificial intelligence, according to several sources like Gartner. As you can see in both graphs, in particular, H2O is currently pushing to bring the latest technologies and expand further as new developments are made, always at the forefront of the sector. And so you may ask, What kind of use cases do our customers use H2O for? Well, H2O is applicable for all kinds of sectors. Every time we present H2O to a customer, we prepare examples of use cases that we expect them to use. And we end up having them suggest even more that they'd like to use it for. And we can go through them during the demo. We've seen it used for fraud detection, for predictive maintenance, churn rate reduction, medical diagnostics prediction, and many more uses. And the amount of progress that can be made with artificial intelligence is truly remarkable. And that's a bit of an introduction for H2O. And I will now let Oscar carry on with the start of the talk, H2O GPT. Thank you.
Yep. Thank you so much, Antonio, for setting the stage. So what I like to continue with, I like to continue with this slide from the, this is a study from McKinsey, which basically highlights the fact that generative AI will attribute in terms of value add in business in terms of from 2.6 up to like $4.4 trillion if we get these or like use cases around generative AI be implemented, especially the ones that we are talking about is GPT model or language models, which are basically large language models. And this will impact work activities in businesses from like something around 60 to 70%. That's a huge amount. What it means is that AI, whether generative or non-generative AI, will replace many of these work activities that we do today will be replaced by automation through the solution based on these approaches. But one thing that I like to also highlight the fact that we should not worry about much about that. These are going to replace us as a human. So what they're going to do is mainly replacing job activities. And if you look at the history, what has happened most of the time is that they are really going to replace those with better jobs. So if you look at like automotive industry, before production line that has been introduced by Henry Ford, we had thousands of literally thousands of car manufacturers just in the States. And after production line has been introduced, that reduced to dozens, because many that didn't adapt to these technologies at the time lost the market to those that did, and brought about efficiency. With the efficiency could expand and get the market. So, but what has happened, if you look at now, it doesn't mean that less people are working because of all these automation in the car industry. Exact the opposite, because they have been able to expand based on these efficiencies that they've gained. They've hired more people and with better salaries. So that's, we can expect that, if you're at least looking from an optimistic window of it, this is something that most probably happen. A lot of boring jobs will be replaced with perhaps more interesting and even better paid. But obviously there is a pain at the period that this transfer is going to happen, because we need to learn new techniques, and we need to adopt these new technologies. So that one point that I just wanted to make sure that this been said. And the other point that I like to highlight from this study is the following. Still, the majority of value comes from non-generative AI, and non-generative AI use case where the few example has been mentioned by Antonio in the previous slide. So still the massive benefit it lies into these non-generative AIs. However, generative AIs can generate a lot of new use cases, as well as it can enable these non-generative based use cases that I'm going to show at least one example at the end of today's session. So, and if the questions that where the benefits lies in terms of generative AI, the majority of benefits comes from increase of productivity. So productivity gain is the major contribution of these generative AI, at least at this point in time. And I like this matrix from also this study. It's basically breaks down based on a different business line for a variety of businesses. As we can see, like marketing and sales benefit a lot, because we have here, we can use these generative AI to create content much more easier and much more personalized based on the customers and also the specific products, etc., etc. And the other area is customer operations. You can imagine that every company that produces something, whether physical or not physical, they have customers, and then you need to provide services, and in terms of customer service or other means, that is one of the big portion of the cost of operations in businesses are customer operations or customer services. And now generative AI can basically assist us for these type of use cases, either directly by having a customer-facing chatbots that can tap into a lot of issues that has been resolved in the past, and we have documents from how to use the products up to the issues that's being raised by the customers in the past, and we have resolution somewhere in our database can be used to perhaps address up to 80% of many of customers' inquiries. Or they can also assist to the customer services, because what customer service agents, so the customer service agents could benefit from internal sort of chatbot that these chatbots can talk to existing documents and much more efficient with much more efficiency respond to customer inquiries. The other areas is R&D and software engineering that also been a benefit a lot with these generative AI solutions. Again, what I will be covering today is that obviously a lot of these use cases we know has been mentioned, but the question is that again, how we can run these solutions internally inside business. And this is the focus of today. But one thing that I like to also quickly mention before we continue is that how these models work, and at least in a very, 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 very high level. Some of you may already know the details about, might be expert and know how these models work. But for those that might not be familiar, just wanted to give a high level, idea of how these models work and how they learn. Basically, what these models, these are very, very big neural networks that they're, fed by a lot of text data that we have from Wikipedia, books, and all online text that we have created over the many, many years. These texts are now fed to these neural networks to learn the language, and some other beyond also that these models really go beyond only language. And how they learn is basically if you think about the task that these models need to do is really, really, really simple. The only thing that these models need to do, predict the next word. I mean, technically it's the next token, but if you simplify, it's next word. So given a text like a sentence or paragraph, what these models need to achieve is just predict the next word. As soon as they have the next word, then they need the entire text up to that word that has been predicted will be fed again. And again needs to predict the next word. So with that, word by word, they will generate text. So this is the task that actually these models have to do. But this is, although it's a bit simplified, and but really seems to be a very simple task to do, right? But the consequence of this is the following. Imagine that we have this sentence: the Prime Minister of Spain is. And if we expect this model to correctly predict the next word, and after that the next word, like Pedro Sanchez, these models need to learn how to incorporate knowledge into this neural network, right? And or another example, if you're exposing to this model like 4 + 6 equals, and we expect, these models be able to predict the next word, which is 10 actually. So they need to somehow learn how to do math. So these are the consequences of, these models. What I want to say here is that these models not only learn the grammar of a language, but they're forced to incorporate knowledge, to incorporate, learn certain tasks like doing math. So again, as I mentioned a couple of times, and we have heard, we have seen specifically after the Chat GPT moment end of last year that everyone excited about, the applications that these models have. The idea for us is that, because when we are when it comes to enterprise settings, obviously there are a lot of use cases and the documents, data sets that we cannot send to just using the APIs like from OpenAI or Anthropic and some other services that are available online. We just cannot send the documents to these services. So and in due to privacy and security and so many other aspects. So what we want ideally to be able to do to address many of these use cases, running these models internally inside the firewall of our say IT firewalls, and not requiring to send any data outside of that environment. So why that matters again? I mentioned data privacy, security, the obvious one. So because we have it might involve customer data set that due to regulation we cannot easily expose those data set to any third party outside of the organization. And we have had about data leakage. So obviously anything online has always associated a risk of data leakage. And the internal models, obviously, we have much better control on those aspects. AI governance is another aspect, because we don't really know fully how these models have been generated, what data sets is being used, what are the legal implications of those. But the advantage of these open source models are that we have a full control of first of all, we know what data is being used, how these models have been trained, so we have a much better visibility in that sense. And also the customization, because they are services, these API based solutions are services that are given to us, so we have limited possibility to do this customization. But on the other hand, for these open source models, if we run in our premises, so we have full control how we want to run it, and in what terms, and there is possibility of fine-tuning them further based on our internal data to make it more appropriate to our use cases. And the cost of scalability is another issue, because what happens is that when we start using these API-based solution, at the beginning it sounds like especially the cost is not high, because the users is not that high. But as soon as we start to adopt these solutions, the costs start rapidly to rise. But if you run it internally, we have one advantage is that we can use the model, especially from the size of the model, because you might have heard that there are different models, but they're different size, so we can pick the right size that fits better for our use case. And also typically it's associated to a fixed cost, so we run it in our hardware, and that it doesn't matter how much we use it. It just the costs are fixed. Availability, again, downtime, it's out of control if it's API based, but if you're running internally, we can control that. Ownership, so obviously they're not owned by us, but we can own, like, you know, fine tune the models and own it, and you know, make sure that it sort of contains our, you know, the IP of that model is in our hand. And again, we can easily replicate the solutions. So now I like to give a few examples here, see that how we can use these models, a few examples, and how we can, you know, sort of also impact the response that we can get from these models. So I'm going to start from first this question. That's a centuries question, especially if you're Spain. You know, that's one of the most important question. Obviously, I mean, I guess for half of the audience, they know the right answers, and also the other half also know the answer. I know who's the superior. But I like to use a GPT. Before I used this, I like to also highlight the fact that H2O GPT, the core product, is open source, so you can simply go to our GitHub and, you know, follow the instructions and run it even on your laptop. So these models can run on your laptops, and, you know, obviously for smaller models. So if you have a big model, so obviously you need a much better, stronger machines and, you know, GPUs, etc., etc. But you know, you can run smaller models simply on your laptop by following the instructions. Yeah. So and you will get an interface like this one here. By the way, this is open, so anyone can go to GPT, that is H2O.ai, and start chatting. So let's see if we put here what we get as a response. Now, the thing is, you might notice now I'm talking at the same time with 4 different models. One from ChatGPT, so this from OpenAI, and the rest are open source, these 3. So at the same time, I'm able to talk with many models. So internally, I mean, potentially I can run many different, even more, and, you know, type a question like this, get the response, compare the results, at least to give a feeling that, you know, for this type of use cases or the questions that I'm asking, in which model basically works okay for my, or work best for my use case. And why I want to do that, because if you look at different models, this is 7B, 13B, so this is like twice, a bit more, like, you know, a bit less than twice of that one, and this is like 10 times bigger than this one, and this is from OpenAI, is like, you know, 50 times bigger than this one. So as the models becomes bigger, so we need more GPUs, so if it would be more expensive, and on the other hand, it will have more you know, carbon dioxide footprint, etc., that, you know, if you're conscious about those aspects, we don't want to you know, waste you know, by using a unnecessarily big model for use cases that can be addressed by small models. So so again, the advantage here is that, you know, we can run smaller model, but we can also run multiple models to get a feeling of which models can work better for our use cases. And if you look at this one specifically, in these 2 upper, and, you know, I personally prefer these type of responses, right? So in the debate about, you know, it's a bit lively, you know, it's more natural than, let's say here, this one as an AI language model. I don't have personal sense. Quite boring, isn't it? Despite the fact that these models are much smaller. And the other thing that I wanted to mention here is that we can control the way that these models also respond. By giving some context to these models. So I can tell this model that, you know, imagine I'm building a fun application. So I want to be saying that this model be funny. So let's go back, clear here, see how. Okay, move the question itself as well. You get question. So now, as you can see, now the response changed a bit, right? So it's starting out, oh my gosh, this is the most important question I was told, etc. And or here, you see, I influence the way that now these models respond. By the way, this one probably is not appropriate for this type of use case, right? So they started only sending out emojis. So what I wanted to say is that we can simply run these models internally. We can influence the way that they are responding by simply providing a very simple, something that some of you might be familiar with, like called prompt engineering. Basically, we give context, or we give direction how these models should respond to our questions. So, okay, these were a bit like not necessarily business oriented use cases, but imagine now we have a case where we are running a business, and we receive customer feedback, whether that feedback is and online, reviews, or just an email customers sent to us, something like this, like I was shocked at how unprofessional the staff was at this store. They were gossiping, laughing loudly, completely ignoring customers, and it was a terrible experience. So what I can do typically here is that I want to respond to this customer and apologize, or build an application that does certain thing based on how the customers give us review, feedback, and maybe we want to give a promotion or some things like this, create application on top of that. So again, what we could do is apply certain type of prompt engineering and give direction to these models to respond, or if you want to send an email or in different ways to respond to that customer, we can have a prompt engineering, something like this. It gives direction to these models that how to create a response for me, specifically because if I'm going to create an application, I expect the response to be structured like this. Let me give me a sentiment, give me a reason why customer is not happy, and create a response that I can directly send to that customer. So now let's work out this example. Let's clear this again here. I'm going to do what first, provide the directives here again. So I'm going to I'm going to give a customer review. So my assumption is that this model is going to be used for this application. I'm going to provide that. That I'm going to provide a customer review and give me a response with that format. Now I'm going to do the chat. For the sake of time, we'll copy the. So that's the customer. So I was shocked, and the same review that we just saw. Now I'm going to give submit. So as you can see, they started to generate responses. So sentiment, negative. So all more or less the same. Reason, the customer felt neglected, disrespected, etc., etc. So gave me a reason, and prepared also for me an email that I can send it out. So I can basically integrate that, and also this is important. Even if you're running this system internally, you will get an API. So the system will expose you an API that can be used by application. So those applications can parse now this response, and based on whether that's negative or positive, you might take some actions, and you might store the reasons for further analysis, and you can use response this by replacing the name of the customer, sending that email right away to the customer. Or you might want to take different approaches, but they're completely automated, like this message can be sent out of the box. Or at the beginning, perhaps you want to have full control, like editing the email before it's being sent out. Again, another aspect that I quickly want to emphasize is that now the fact that we can automate this opens up a lot of opportunities. What it means is that now I can have more control on the tone of the email. So, for example, I can go here, this place like response. I read that compose applied and put the message addressing the customer experience. Now I can change it. Imagine that I know the customer who I'm dealing with, and that's Generation Z. So I don't want to be too formal in that case. let's copy here the question and clear response. And now I'm going to ask, or like give the same thing here. Now see what happened. So you'll see now the tone has changed a bit. Hey there, we're sorry to hear that. You see the message is now more sort of aligned with that generation. So again, this is the advantage of automation, right? So depending on who we are dealing with, the demography, etc., now we can align these messages to be more aligned with that with our audience. Something that typically if I wanted to write this manually before, I needed to think about all the aspects, and whether that's it's early morning after I had my coffee, or afternoon when I'm tired, I might write these messages differently. But now that we can automate that, and on the other hand have a full control, or like almost full control on the way that they are responding, we can automate a lot of these use cases. And what is also interesting is that now we can go one step further. Imagine that you have been running your business for many years, and you have a lot of these examples of how you responded to your customers, and some of those responses maybe picked very well and received very well with your customers. What you can do now, use those examples to fine-tune these models further, and as opposed to just using these out-of-the-box models that are available, pick one of these models that you think it works better and fine-tune that. And go here and create applications that can add, and again, address a variety of different types of use cases. One quick point before we continue, I'd like to here mention that if you're going to create applications like this, obviously there are certain building blocks that we need. So it all starts with your data. Obviously we need you need to have certain documents, and based on that create these applications. And then one step is that we need to prepare this data, and what it means for example, if you want to fine-tune a model for a specific use case, you might have documents or text internally that you want to use for fine-tuning. One approach is to create sort of instruction pair, sort of data, so like answers and questions and things like this. So we need to have tools that facilitate that. What we in H2O support is that we have a tool called LLM Data Studio, which will basically facilitate that process. The next layer is obviously we need to pick one of these open source, or a few of these open source for fine tuning, and on top we need to create finally our application. That one application I will use today for the demo to see how it works. However, one thing that I like to also mention here is the following. This is a tweet a few days ago from a CEO of Hugging Face. That basically what he says, that 90% of AI use cases can be addressed by smaller models, which are also specialized for certain tasks. So what it means is, as opposed to using really these big models from like OpenAI, or really big models that are very generalized, why not use very specialized models that can in many cases can address many of the use cases? And actually what we could end up having is essentially having different smaller specialized GPT model for different business line and use cases. Again, another basically highlight on why this approach works better. So again, here a short summary of the use cases that these models now can be fine-tuned and applied to. From the range from HR and marketing, like content generation and customer care, as mentioned earlier, either building application on top of the knowledge base that we have internally, to supporting ticket resolution, etc. As I mentioned here, when we're talking this past, that another next step would be that we could take is use the internally available data set to fine tune these models. What we offer at H2O is H2O LLM Studio, which simplifies the process of fine tuning. And the reason for this is that fine tuning could be a bit tricky because, first of all, that's really expensive, and on the other hand, there are many different techniques that we can utilize to do the fine tuning. And some of you might be familiar with lower techniques, creating checkpointing or quantization of this model to manage the GPU consumption. What LLM Studio does is that it's first of all a no code environment application, so you don't need to write even one line of code to achieve these techniques. You just the thing that you need to do is, as I mentioned earlier, you need to create the pair of instruction and output example, like question and answer, or if you want to fine tune for emails, it would be your email and the responses that you have created, or customer review, the responses that you have created. So these kind of pairs. And then we load the dataset in LLM Studio, and perhaps the most important settings here is that we need to select a backbone for our models. Each of these open source models that I mentioned earlier could be a good start. We're going to select that one, and if you're familiar with any settings, we can adjust it, or otherwise we can go with the default. And it will train and based on our internal data and makes it ready for deployment. And we can directly push it in Hugging Face, or we can download it and deploy it internally. And one feature that I really like is that as soon as we create these models, or if we fine tune these models, we can go ahead and chat with this, because we can get the immediate feeling that how after fine tuning really these models behave. And one data point to prove that really excels to does the job. I don't know if everyone is familiar with Kaggle web page or like platform. It's a platform for data scientists to compete either for prize or fame. And H2O team using LLM Studio has been able to be #1, winning this competition for this specific competition. LLM science exams basically was the idea was to use LLM to answer difficult science questions. And again, our team using LLM Studio won this competition. So that's a proof point. Another interesting use case here is that for Lois, he used LLM Studio to basically what he did. He used his email and the way that he would respond, or his response in the past, and fine-tuned one of these open source models so that these models now can respond, or at least craft a draft of an email the way that Louis personally would do. So like imitating his sort of personality, the way that he responds to emails. Again, I mean, these are a few examples, but obviously, there are many different business examples that can be used in real case. So now I'd like to demo, that's not exactly a demo, but a video of Enterprise H2O GPT. So that is one of the most, I would say, popular example of LLMs in enterprise setting, and that's some of you might be familiar with the term RAG. So it is basically chatting with our documents. So you imagine we have PDFs, many variety of different documents, knowledge base internally, and what we want to do is starting chatting with these document and responding questions either internally or externally. And here a short video of how this would work. So simply you can we would create a collection here and then upload any documents that is relevant for this specific use case. In this case, I'm using Q&A from Turkish Airlines that I've just downloaded and created a PDF and loading into application. And now what happens is this data getting indexed and is stored in the system to be used later on to answer questions relevant to these documents. So now I'm going back into this collection that I've created, Turkish Airline, can I start chatting question and by submitting questions. So now what happened here is just a simply ask question. I haven't, let's start a bit, should have been N. I have an economy class ticket. Can I take more than one bag with me in the cabin? So obviously the response is no, and so it responded correctly and based on actually these the documents that I have. So he crafted a response, not just copying pasting what is in document, but crafted a response based on what are available in these documents. So what is also important is that in RAG solutions like this, what we want to know, because one of the issues with LLMs are that you might have heard also that they hallucinate. So they are not, strictly speaking, accurate with information. So in order to alleviate that, that's one approach that we do. We provide the grounding, like the basis information through the documents that you have seen that we uploaded here, right? So this provides the references so that LLMs can use to answer our questions. And now that I have this response, I can look at the reference and look at where this model, which piece of information this model has used to respond my question, and also highlights the fact that this is the area that this model has used to respond to my question. So I get I can like validate their response by looking to the references just to make sure the questions being responded correctly. And also, again, that's another example, just to change the economy to business, and this time, yes, and also use the more or less the same part of the document to respond. So that's basically, again, available. We can run it locally, and these LLM models run locally. So the same LLM models behind this application that you see basically powers this application to enable chatting with these documents. All right, so that's one application. And the other application that I like to show is based on, we go one step further and we use other models that we might have internally, other basically non-generative models that we might have internally, utilize that and create application that basically for a use case and customer related use case we're going to see. But before that, I'd like to highlight a couple of things. In order to have a full ecosystem, I like quickly, I'm not going too much in details, but a very high level, what components we require to build applications such the ones that we've seen and the one that I'm going to show shortly is the following. So it all again starts with your internal application, and we need to prepare this data set or this internal documents that you have. Using LLM Data Studio, we can create QN pairs and things like this. And using LLM Studio, we can fine tune these models and then finally deploy these models so that we can utilize and expose the API and interface so end user can talk with these models. And the other type of application is RAG based that we have seen, like enterprise H2O GPT. We need to index the document in a vector database and use that to respond to the questions that we have seen, like the Turkish Airlines example. What we can do is additionally, now many of us have already have models in production, like in terms of customer related use cases. We might have customer churn, we might have, you know, next best actions or next best offers type of models that are running already in production. So we can also, you know, when imagine when we are creating or doing marketing or running campaigns, we can be very hyper personalized by utilizing this information and or any customer, you know, interaction that we have, information we have internally, and craft you know, sort of campaign that is very personalized. And this is one example that I'm going to show. So the personalized messaging, again, and other applications that we can build on top of these applications, on top of these models. So here, this is actually App Store that Antonio has mentioned earlier. So we can build applications, whether non-generative or generative, and host here. And here you see a big list of, you know, generative AI related use cases. And the one that I like to look at would be next best conversation. So this is basically powered by two things: next best offer and which is non-generative, and the crafting of a messaging to the customer based on LLM model. So imagine I want to write something for this person, for this specific customer, and I have access to information like, you know, churn probability, and, you know, again, as mentioned, what this customer might be interested. I might have a model for it internally, and I can use that to craft a messaging or campaign to this specific person. Again, as like previous examples I mentioned, we can have a fully automated solutions, or what we could do, because we know that internally we have a model that, you know, gives a likelihood of what this specific person might be interested in, but we can control what really we want to offer. You know, I can say, okay, this is good one, this is good one, this is perhaps not. So I can, you know, be a bit more flexible and really I'm interested in to send this person, having full control, and then say, create a personalized email. So now, based on the information, what this person is might be interested, and what I've selected, and it crafts for me an email that I can write about, send it back to this person. Again, this is another example, but there are many examples. One would be, you know, scam detection, whether when we are receiving emails or you know, messages. We can also create applications that use these models to assess, you know, how likelihood is that this message that comes from our business is scam or not a scam. What could be indicator on it, and, you know, many other examples that you see here. But more or less that's what all I wanted to cover. But before I finish up, I'd like to also mention another point, and that is, you know, some of you might asking, you know, is that really, you know, are these models really work in production? Are there examples of that, you know, these uses are being really implemented down? So yes, obviously with many of our customers, we are at the beginning, so, you know, the journey, but already there are solutions that have gone into production using H2O's solution for these type of applications. And with that, I'd like to thank everyone for taking time and joining our webinar. And if you're interested, feel free to reach out to us, going through that, you know, link here, and schedule a demo for more details and in-depth discussion.
Great. Thank you so much, everyone. And we look forward to seeing you in our next webinar. Thank you.